Okay, hello, children. I'm just going to teach you all, okay? Okay, hello, children. We are learning about this is the finishing of your lesson today for section 2.4. Only two more pages, so it shouldn't take us very long. Okay, so we're talking about standard deviation for grouped data. Um, this is for if you're trying to take the standard deviation of a frequency distribution. Okay, the formula is for sample standard deviation, you have S represents our sample standard deviation. And then here's our formula. It's the square root of the sum of x minus x bar squared times the frequency for each class. You divide by n minus 1, which is the 1 minus the sample size. Okay. Also, whenever you do this, you're going to need, whenever we do this next example, it's going to be asking us to find the sample mean as well, which for a frequency distribution has the formula x bar equals the sum of x times f divided by n. And so looking at our frequency, our distribution here, we are going to create our frequency distribution using this data set. Okay, so we want to fill out our frequency column here. We count up the number of zeros, number of ones, and so on. Okay, so first start with zeros. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I think that's it. For ones, we've got a bunch of them, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Twos, 2, 3, 4, 5, 6, 7. Yep. And I'm pretty sure we have 7 threes as well. 2, 3, 4, 5, 6, and 7. Nope. For fours, 1, 2. Is that it? Only 2 fours? For fives, 1. And then for sixes, 1, 2, 3, 4. Okay, all of this should add up to 50 because there are 50 entries in our data set. Okay, so to find our sample mean, because we're going to need this x bar right here eventually, we have to use this formula, but we have to find all of our xf's first. This is just x times f, so we'll take this column, this x column, multiply by the f column. It's 0, 19, 14, 21, 8, 5, and 24 for a total of 91. If you add them up, if you add all those up, you get 91, which is the sum of xf, which is the top of our sample mean formula. So x bar is just going to equal 91 divided by the total number of entries, which is 50. You get 1.82. So in this next column, we're doing the x column minus whatever we got for our x bar, which happens to be 1.82. So we'll take all these numbers in the x column and subtract 1.82. So this will be negative 1.82. Okay. Then negative 0.82. Then 2 minus 1.82 is 0.18. Okay, and then we'll do the same thing. This is 1.18, 2.18, 3.18, and then 4.18. Okay, then our next column asks us to square these values. Okay, so let's do that. 1.82 squared, 3.3124. 0.6724. 1.3924. 4.7524. $10.1124. 17.4724. Okay, now you see this next column. We're taking this previous column we've just done and we're multiplying by our frequencies. So this first one becomes 33.124 because it's this 3.3124 times our frequency of 10. And then from there, we just do the rest of the multiplication. So 0.6724 times 19, 12.7756. Okay, 0.0324 times 7 is 0.2268. 1.3924 times 7 equals 9.7468. Okay, then we do 4.7524 times 2. That's 9.5048. Then 10.1124 times 1, of course, is 10.1124. And then lastly, 17.4724 times 4, 69.8896. So we'll add all these up together to get the sum at the bottom here, which that sum at the bottom of this last column is the same as the numerator of the fraction in the formula we're going to be using for sample standard deviation. Okay, so add all these up. We get 145.38. Okay, so our sample standard deviation is going to be the square root of 145.38. Divided by, so we said that this numerator was just the sum we just found, and then we're dividing by n minus 1 this time. If n's 50, we would be dividing by 49. Okay, so doing that, and then taking the square root, we're going to get approximately 1.72. Wonderful. Okay, so that is our sample standard deviation for this frequency distribution. All right, so to save time, I'm just going to kind of explain what you need to do for this next one. You can do it on your own. Okay, so x in this case will be the midpoint because it says using midpoint. So the figure shows the results of a survey in which 1,000 adults were asked how much they spend in preparations for personal travel each year. Make a frequency distribution for the data, then use the table to estimate the sample mean and sample standard deviation of the data set. So for this one, your x values will be your midpoint of the of the class. So for example, to find this one, 99 plus 0 divided by 2, that would be what, 49.5? And this one would be 149.5. And then this would be 249.5, 349.5, 449.5, and 549.5. Okay, now your frequencies are found from this table, right? This picture up here. Okay, so for 0 to 99 or less than 100, we have 380. Okay, for 100 to 199, you have 230, then 210, then 50, then 60, and then 70. Now from here, the process is the same that you did up here, so I'll let you finish that on your own. Okay, find XF, you multiply to find XF, you multiply your X's column times your F column, and then you need to find your sample mean, finding the sum of this. Okay, you also need to know what this is. Okay, this is going to be your N whenever you find that. Okay, this XF, you're going to be taking that, dividing by your N to find the sum of your XF divided by your N to find your sample mean, which is X bar. And then from there, you can finish the rest of that. Okay. But just for time purposes, I won't go ahead and do the rest of it. But I started you off on it. Okay. Lastly, we have what we call the coefficient of variation. Okay. What is the coefficient of variation? So, give me 1 second. Coefficient of variation. To compare variation in different data sets, you can use the standard deviation when the data sets use the same units of measure, and the means approximately are the same. Okay, however, for data sets with different units of measure or different means, we use the coefficient of variation. Okay, so the coefficient of variation describes the data, describes the standard deviation as a percent of the mean. So for a population, right, the coefficient of variation is just the population standard deviation divided by the population mean times 100. That'll give you as a percent. Okay. Now the sample, same thing, the same formula, except we deal with the letters for a sample. Sample standard deviation is S divided by the sample mean, which is X bar, times 100%. So the formula is the same, of course, but for sample and population, they're just different variables here. That's the only difference between the sample and population formula. Okay. So for our example here, our last part says this table shows the population, heights in inches, and weights in pounds of the members of a basketball team. Find the coefficient of variance for the heights and weights, then compare the results. Okay, so I'm going to use technology to find the mean and the standard deviation. This is a population, okay, and then we'll compare the results. Okay, so I'm going to type this into my calculator real quick. I will show you how to do this later. Okay, so using my calculator, I found that the mean height, let's do heights, and then weights. Okay, the mean of the heights, this is a population, is, my calculator tells me 72.75. Okay, and then I'm going to do the standard deviation for a population, which is of my standard deviation for the population is 3.29. So again, I found these by using my calculator. Again, I'll show you all how to do that once we have the calculators back. But for this, for the case, for the, what am I trying to say? For the example here, we're just going to show you how to find the CV, okay, which is the standard deviation divided by the mean times 100. Okay, so 3.29 divided by 72.75 is about, times 100 is 4.52% about. Okay, now for the weights, let me do that as well. Type those in: 180, 168, 225, 201, 189, 192, 197, 162, 174, 171, 185, and 210. Okay, so the mean of the weights is about 187.83 using my calculator. And the standard deviation for this one of the population is about 17.69. So our CV for the weights is 17.69 divided by 187.83 times 100. Okay, so 17.69 divided by 187.83 is about 9.42%. Okay, so I guess let's compare these results. The standard deviation as a percentage of the mean height is lower than the standard deviation as a percentage of the mean weight. Okay. All right, that's the end of the section. There we go. And that's it. Thanks, guys. Boom.